Welcome to the debate. Imagine you're building a massive high-speed transit system, right? Do you want a bullet train forged in structural steel running on a highly engineered, predictable track? Or do you want
a heavily modified sports car driven by a caffeinated stunt double?
Yes, exactly.
Well, I think you mean a highly agile, all-terrain vehicle that, actually gets built before the decade is out.
Right. Well, today we are looking at the ultimate architectural showdown, Java versus Python. If you look at the recent benchmarking data, the trade-offs are just glaring. I stand firmly with Java. It is the only responsible, scalable choice for high-performance enterprise architecture.
And I am defending Python, the undeniable champion of developer velocity, data science, and, dynamic agility.
The energy benchmarks alone paint a brutal picture. Python consumes up to 22 times more energy for computational operations than compiled languages.
Okay, but
It's an ecological and financial disaster at scale. And don't even get me started on dynamic typing.
Oh, come on.
Without strict compile time checks, type errors hide in your codebase like landmines. They just wait for that exact line of code to execute in production before blowing up. That is a chaotic recipe for a 2 a.m. outage.
Oh, please. You don't build modern systems by wasting half your life writing boilerplate code just to satisfy a compiler. The most expensive resource in any enterprise isn't CPU cycles, right? It's developer time.
Is it though?
yes, Python's clean syntax allows teams to actually ship products. And let's address this whole slow narrative right now. Python intelligently delegates heavy computational workloads to highly optimized C and C++ libraries.
Sure, but it's still Python at the top.
But Python isn't actually doing the math. It's just the steering wheel for an engine built entirely out of C++. That's exactly why it maintains absolute dominance in the machine learning ecosystem with frameworks like, TensorFlow and PyTorch.
Having a C++ engine is great until you need true concurrency within your own application.
Here we go with the GIL.
Yes, the global interpreter lock. Python's infamous GIL is a hard ceiling. It's like having a massive 16-lane highway, but the toll booth operator only lets one car through at a time, no matter how empty the other lanes are.
That's a bit dramatic.
It's true. You can throw a 16-core machine at a Python API, and the GIL ensures it basically runs on one core. Java's JVM, on the other hand, was built from the ground up for true parallel execution.
True parallel execution, yeah. Eventually, once it finally wakes up.
What do you mean?
I'll take the GIL over the JVM's sluggish warm-up period any day. The JVM spends its initial moments obsessively profiling the code to identify hotspots for its just-in-time compilation.
Well, that's how it gets fast.
It's trading slow startup times for long-term speed. But while Java is busy doing bureaucratic profiling and demanding a 200 megabyte baseline memory footprint before executing a single line of code, well, Python processes have already spun up. Python starts instantly and fits perfectly into 256 megabyte serverless pods. Java just eats your cloud budget.
I see why you think that, but let me give you a different perspective. Sure, a 256 megabyte pod sounds great for a tiny microservice, but when you scale that up to a massive financial architecture, your rapid prototyping turns into duct tape.
Duct tape.
Yes, duct tape. It holds together just long enough to pass a demo. Java's strict typing gives you structural steel. And when things do go wrong, we have Java Flight Recorder.
All right, the black box.
Exactly. A low-overhead profiling tool built directly into the JVM. It lets you perfectly reconstruct the exact moments before a crash, like a black box on an airplane. When you're handling millions of transactions, you need that steel to trace exactly what happened without guessing.
I'm sorry, but I just don't buy that. Let me tell you why. Your structural steel looks a lot more like bureaucratic red tape.
How so?
Java is infamous for its dependency hell. When you pull in Spring and Hibernate, you aren't just downloading code. You're inheriting a massive legacy dependency tree that bogs down every CI/CD pipeline you build.
That's an exaggeration.
It's really not. Suddenly you're deploying bloated 500 megabyte plus Docker images just to say hello world. Python gives you lean agility. When a critical vulnerability drops, you aren't fighting through a massive, archaic dependency graph just to patch a simple service.
Well, it seems we are looking at two fundamentally different architectural philosophies. On one side, Java offers predictable long-term performance, incredible energy efficiency, and the observability required for massive scale.
Right. And on the other, Python delivers unmatched rapid prototyping, developer velocity, and the entire modern machine learning ecosystem.
Which means the smartest architectures don't pick just one.
Yeah, I can agree with that.
If Java is the structural steel and Python is the duct tape, then the modern enterprise actually requires both. You use Python for high-level ML orchestration and rapid data modeling while relying on Java for the heavy, concurrent transactional kernels.
Exactly. You use the agile all-terrain vehicle to scout the new territory and prototype the AI, and you bring in the bullet train when you need to move 1 million transactions a day safely.
Very well put. We'll leave it to our listeners to evaluate their own system's architectural needs. When you look at your next major deployment, ask yourself, do you need the duct tape or do you need the steel?